Welcome back. I'm happy to introduce Daniel Kessler to you. He is a development engineer for smart sensors at Balluff, and he will combine several previous sessions in his topic. This is called smart condition monitoring using Balluff condition monitoring sensor and machine learning. But Daniel, don't you think we should have a coffee break first?
Thanks for the introduction. Let's talk about coffee. Coffee is the most popular drink in the world, and many people cannot imagine everyday's life without a coffee. You wonder why I talk about coffee in the terms of smart condition monitoring. Today I will show you a demonstrator how to use machine learning using a coffee machine. Therefore, I hope you will get an idea how machine learning will improve your process. So first of all, I will start with some basic background information, and later on we switch to the live demo. So first of all, we have to talk about what values will be added by the use of machine learning. Therefore, we have to say you can improve your process quality. This means you are able to say, okay, if I monitor certain variables in my process, I can use machine learning to see, okay, if certain parameters of my machine will change their values in a specific way, it is likely that my scrap will increase, or I have quality problems. So with the use of machine learning, you can detect those process parameters, and now you are able to perhaps fix those process parameters to get and improve in your process. Another thing is you can have a decreased downtime in the terms of a predictive maintenance system. So you can train your machine learning model, and you are able to predict when the next failure will happen. Will it be in a few days, weeks, or months? And therefore, you can maintain your machine before this event happens. Another thing is the detection of anomalies. So if you can think of your machine and you train your model, to your current stable state of your machine, and you want to detect any outlier of your machine to be classified as an anomaly. And then you will be able to say, okay, I want to be notified or messaged with this, and you can see, okay, if there are certain values in my process are drifting, or if there are long-term drift, should I have to take actions, or is this okay? So you can detect anomalies with that. Therefore, all these points, I show you my demonstrator using machine learning and a coffee machine. To be more precise, I use the vibration of the coffee machine to classify which coffee type is currently made. So, first of all, we have to discuss what do we need for this. One thing is the sufficient and qualitative data for the training. This means sufficient, you have a minimum amount of data depending on your chosen application and your chosen machine learning algorithm. One rule is the more data you have, the more precise your algorithm gets. Another thing is you need qualitative data. Qualitative data means you should not have any missing values in your data set, you should not have any errors in your data set, and you should not have any wrong labeled data sets. Wrong labeled means if you have a data set, for example, in cappuccino, but it's wrong labeled as an espresso, and this will disturb your training and you get a poor training result. Another thing is you need a suitable machine learning algorithm. This means you have to choose the right machine learning algorithm depending on your application. Every machine learning algorithm has its pros and cons, so you have to choose wisely. So here's a little selection of the machine learning algorithms. You have to, that's some basic knowledge you need to choose the right one. Another thing is you need some device where you're able to run this setup on. So in this case, it's an edge device for an online classification. Online classification means it's a real-time classification. And therefore, this edge device is a Raspberry Pi. This Raspberry Pi is able to perform this computational power for this task. Another thing is, as I said, we have here, I want to measure the vibration of the coffee machine. Therefore, I need a sensor. Here I use the Balluff condition monitoring sensor, the BCM. The BCM is capable of measure the vibration in 3 axes, and also I have to access to other parameters as contact temperature and so on. And last of all, I need a sufficient data pipeline. A data pipeline is capable of getting my sensor data directly from my sensor to my machine learning system. So I'm able to say, okay, classify which coffee type is currently made in real time. Let's look at the data pipeline. So it consists basically of 4 steps, and is separated in an offline mode and an online mode. The offline mode is there to collect the whole data set, so all coffee types, beforehand, and then use it for the training. The online mode instead uses a small data set to classify it in real time. So as I said, in the offline mode, I collect the whole data set, including all coffee types, make some pre-processing steps out of it, so make some scaling and cleaning of the data, so my data is now ready for the training process. Then I start the training process, so I used a neural network, one-dimensional CNN and convolutional neural network. After this training is done, I have the trained neural network, which is now able to classify which coffee type is made. So if we switch to the online mode, we collect data in a smaller time window, so in this case, in a process window of a coffee. Then we make the same pre-processing steps and feed those data to my neural network. This neural network classify now which coffee type is made. So, as I said, we have different coffee types we want to distinguish between, and here we have 10 different coffee types. And as you see here in the chart, we have different. You see here in the chart how much training samples per coffee type do we have. And you see here we have much more data for the double coffee, cappuccino, or latte macchiato in comparison to a milk foam or a milky coffee. So this leads to one problem. If I would use this training set as it is here, it would lead to one thing. The double coffee or cappuccino is more represented in my data, so it will be more included in the training, and later on in the online mode I have less accuracy in other classes. Therefore, I have to make some balancing function in there. So I apply a balancing function to make my data set somehow balanced, so the milk foam get a little bit higher importance, and therefore over average we have a balanced data set. So one thing here is, the next thing, we have is vibrational data here. So this is a typical coffee where the vibration in 3 axes is shown. You can separate it in 3 phases or in processes. It's the grinding process, the brewing process, and the cleanup phase. And as you see here, the brewing process, you have little changes in your vibration in there, and this is one typical pattern for a normal coffee. So each coffee type has its unique vibrational pattern, and for this unique vibrational pattern, I'm able to distinguish between different coffee types. So let's look here at the espresso or cappuccino. You see they both start with the grinding process. But in the cappuccino phase, you see there are little spikes in there, and these spikes are there when the milk pump is going on, and you have to for the cappuccino. So with this background information in mind, I will switch to my dashboard and later on to my live application. So if we see here the dashboard, you see here on the left top side the coffee machine with its sensor location. And if I click here on the red bubble on the top, you should see here the diagrams with all the vibrational patterns, and also the vibration in 3 axes, and also the contact temperature. In this case, I only use the vibrational parameters in there. If we switch back to the dashboard, you see on the top, here it's displayed which coffee type was classified. You also see at which time does it, which timestamp is it currently. You see, okay, coffee statistic for the last hour, so which coffee type was made during the last hour, and you see a machine utilization in the last hour. On the bottom, you see how much coffee types were made in the last 3 days, but it's only showed for today. So with this dashboard in mind, we switch to the live demonstration. So I have to use my cup, and here's the coffee machine. as you see beforehand, the BCM is mounted on the top. This BCM is measuring the vibration of the coffee machine. One BCM is here on the front. This task of this BCM is only to visualize the humidity when the steam from a coffee is rising up or from a cappuccino. And also you see here is the ultrasonic sensor, and this ultrasonic sensor's task is to set a trigger signal, so I know I have to start my process. So if I put my mug here, the ultrasonic sensor sends a trigger signal, and now the process starts. So I think we started. I place my mug here, press on coffee, and now in the live data, you should now see that it's loading. Here you should you would see the coffee brewing process in there, and I think no. You would see the coffee making process in there. You see the grinding phase, the brewing phase, and the cleanup phase. And after it is done, I will remove the mug, and my trigger signal for this will going to now. And my algorithm knows, okay, it's ending. Now analyze it and make the classification out of it. So currently it's brewing, and we have to wait a little bit. Now the cleanup phase is going on. And now if I remove the mug, it takes a little seconds, and you see right there, if it doesn't hang, oh, I think it's still stuck. So it should here be, you should see here the last ordered coffee was a coffee, and it's at this timestamp here. So in sum, I can say, I can classify which coffee type is currently made according to my vibrational pattern. You think, okay, this is coffee machine. How can I use this for my machine, for my real world machine? So you can use this algorithm also on any vibrating or rotating machine where you know your states. If you don't know your states of the machine, you cannot apply this algorithm. Therefore, you can use an anomaly detection. So you know your stable state of your machine and want to be notified when anything, any unnatural behavior of your machine occurred, and you can react to this. I think it's time for the coffee and answer some questions here.
Thank you, Daniel, for that great demonstration. So there is already a question in our chat. How do you balance your training data? Do you simply double the inputs for milk foam, or is there a more elegant way?
Yeah, it's basically somehow you can give your training algorithm somehow the weighting function in there, and it looks like the distribution of the data, and it's not only the double of the milk foam. It's a little bit more complicated than this. But you can say, I don't know how to say it in a simple way. Okay, basically you can say it's simply a double importance of the training data in there, and there's no more elegant way in there. So you should consider to have an equal balanced data set to do not have this problem at all.
Let's stay a little bit with the training data. How many data sets are necessary for a training?
This depends on your application. So if you have, in this case, the more coffee types you have, you need more data. The more, the similarity between certain coffee types if they are more similar to each other, you also need more training data. For example, here, then espresso and then ristretto data is much more similar to each other, and therefore the algorithm needs more data to distinguish between both phases, or between both coffee types.
Okay.
Yeah.
And can you tell us something about the accuracy in live operation?
Yeah. Here the accuracy in the live operation is about 90%. It's not this good for a machine learning algorithm, but in this case I do not have enough data for my training. And also I have this problem with the similarity between a ristretto and an espresso. So I have to choose. I need more data in this case, and my colleagues only drank double coffee and then cappuccino and so on in this case.
So, and now we saw that we can distinguish cappuccino from espresso, but how can we transfer this to an industrial application?
Yeah. So if you know your states of the machine, so if you say, okay, my machine has possibly 4 or 5 states, you have to capture those data from this. You place your BCM on rotating axis also or other locations, collect this data, and then later on you start your training process, and now you're able to say, okay, according to my vibration, I'm currently with a likelihood of 80%, I'm in this current state. So you can, but you have to keep in mind, you can use this only if you know the state of your machine. The other thing is you can use an anomaly detection system out of it, so you only need to know one state of your machine.
Okay, thank you, Daniel, for answering the questions. And thank you all for listening. We will have a short break and we will be back at 2:30 with our next session. Thank you.